Hello and almost good afternoon. Thanks that I could do this via Zoom. I'm sorry I couldn't come. And I'm from Kabáth from Astronomical Institute, and I'm leading the Exoplanetary group. And we are involved in the PLATO Space mission business and also in the ground-based support for PLATO tests and basically exoplanetary missions. So, okay, so this is clearly a topic which deserved the Nobel Prize. So the exoplanet is a hot topic, and of course the PLATO mission is one of the flagships which will come. Další, prosím. So the main questions are basically the detection of the first exoplanet around Sun-like stars, so which we achieved already, that we are looking for our place in the universe. And then, of course, one of the motivations was that there was this topic not done in Czech Republic. So it was something new. Now I think we are quite established. And the bigger questions, of course, are that we would like to understand how many planets are, how many planets are in the universe, how do they evolve, and how do they compare to the solar system. So the idea is that if the solar system is unique, or if the solar systems are common like ours. So this is what we have to see, and this is what, for example, the PLATO Space mission is going to resolve. And then, of course, the life in the universe. Další, prosím. So where are we now? The idea is that we should know about, or we know about 5,000 planets, rapidly increasing every day, virtually, literally, because of the space missions like TESS, and it was Kepler. Další, prosím. Then, as I said, that there will be a PLATO space mission flying in 2026, and this is the part of our main program. And this is also the part supported from the AV21 program. And we are involved, we are contributing to software, to space mission, and in collaboration with the Saab Aerospace from Brno, we are contributing also hardware, the transport containers for the PLATO mission camera. Další, prosím. So the idea of the PLATO space mission is monitoring of 1 million of bright stars. We of course need very thorough follow-up of these targets, just to be able to confirm all the candidates and to turn them in planets. And then, of course, we would need about 50 nights a year on 1 or 2 meter facilities. And basically every spectrograph on 1 to 2 meter class telescope counts. So this is the reason for another project, which is supported from AV21 program, which is the spectrograph PLATOSpec. Další, prosím. So on the next slide, there is a PLATO mission design. So there are the CCDs visible. And our contribution is set, apart from software, is the hardware, so which is the transport container for single CCD, which I will show you later. Další, prosím. I have here, you can see the field of view of the CCD. So this will be how the mission is looking for the targets. The blue ones will be the main targets. Where the mission is going to look for Earth-sized planets on Earth-sized orbits. That means you need 3 years to monitor. Další, prosím. And here is our hardware contribution. So this is the transport containers. I have to say that Saab Aerospace is doing pretty good job. The containers are delivered even in the very difficult environment. And then the second contribution is the software, which is basically the monitoring of the data reduction and the performance of the mission. And this is done by my colleague Marie Hrudková and myself. Další, prosím. And then the last few slides are about the PLATOSpec, which will be the ground-based facility. So next one, please. And this is the ground-based telescope, which is essential for space missions. And this telescope will be installed at La Silla, or is installed at La Silla, on E152 telescope, which was inaugurated in '60s in the past century, and now is operational again because it was refurbished. Další, prosím. The idea for PLATOSpec is that we will put a state-of-the-art spectrograph on the PLATO on the E152, and we will be providing the ground-based follow-up of the target's precise radial velocities. Další, prosím. And here we will be able to monitor all. You can see what we can monitor. This is in red. Descent Plato is the stars which we will be monitoring, and this we will be able to confirm also with our instrument PLATOSpec, which you see on the you can see the aims and the goals on the next slide, and we will be able to characterize stellar parameters. We will be doing so-called initial screening candidates, and we will be rejecting false positives and measuring the masses and radii of the planets. We will be able to get down to few meters per second precision in radial velocities. Další, prosím. Okay, this is only the summary, basically, that we will be, that's what I said. So we can go to the next, where you see the parameters of the spectrograph itself, and where you see an echelongram. So it will be the spectrograph, which has 360 to 680 nanometers coverage, 70,000 spectral resolving power. And the accuracy will be down to 3 meters per second, maybe even better. Okay, so the next one is just an instrument design. And then on the next one, a few results. This is just to see what we got with a different but similar telescope and instrumentation here in Montreal. And this is the 3 new confirmed hot Jupiters. And one is around the subgiant, one is around the main sequence star, and one is around the young star, and it was recently published. So, and the last slide is, so the next one, please. This is just a summary how the AW21 helped, and that we are progressing, and this was, we were able, with the support of this program, we were able basically to get into the PLATO Space mission and to start the PLATOSpec. And if you like, we have on the last 2 slides, there are 2 nice pictures. This is the La Silla and E152, and the last one is then our telescope in Montreal. So thank you very much, and if you have questions, please ask.